Hello, everyone. Let's wait for a few more minutes so that more people could join, and then we will start this Q&A session. All right, well, let's start. So first of all, a short intro. So my name is Dima. I'm leading the European data science team at Aura, which is a smart ring company. We produce those smart rings that measure all sorts of things. I lead this team that develops algorithms that directly interface our consumers. Uh, and those include algorithms in the movement space, activity space, stress, women's health. And today I will be helping you with these technical questions that you might have about the challenge of the menopause prediction and management. Hey, everyone who's still connecting. My name is Dima. So this is an Ask Me Anything session. So I don't have any slides or anything. I'm here to answer any questions that you might have for me about this challenge. And I can also share my view of how you can potentially address this challenge. What are the steps that you might take when it comes to collecting the data, building the algorithms, validating them, etc. So yeah, you can ask questions either way. I have chat open, so feel free to write those down. If it's too tedious for you to write, feel free to use your voice and camera and whatnot. But yeah, let's dive into the challenge itself. So as all of you know, the goal here is to try and predict the menopause symptoms onset before it appears based on any data that you can find. And these could be the demographics features, the genome expressions, wearables data, if you get your hands on that. So all the different sources which you can find in open source or any other places where you can legally get this data. I would say that the biggest challenge here is actually collecting a good data set to train your models. The ML part of it, the machine learning part of it, or algorithm building is not as challenging, it's not as cumbersome as trying to collect a proper data set. So I would advise you to spend as much time and thinking as possible on collecting a proper, clean data set that you can play with. And there are multiple sources. Some of them were suggested by Rebecca with open source data sets that were collected specifically for this problem of menopause prediction. You might as well look for other open data sets like on Kaggle or Open Data or other platforms that you may find. There was also a suggestion to use synthetic data generation, which might be a bit of a reach for the stars approach, because to generate synthetic data properly, you first need a proper reference data set so that you can repeat the same distributions and get the same quality of the data set. So I would suggest to start with open source, with Kaggle, with data sets that you can find from healthcare providers if they're open. That would be an ideal scenario. Next, when it comes to the actual model building, the challenge again here is understanding what kind of model would you build and how to make this interpretable, safe, and easy to explain. Because These are healthcare models, and you're supposed to understand how it behaves, what it does. Black box solutions obviously are fine as well, but ideally it would be great for you to explain the reasoning behind the model, what actually happens in there, explain how different features affect the target variable, and what are the magnitudes of influence. So one of the suggestions that I have for you is to split your work into two streams. One stream would be fully scientifically backed and scientifically proven. That is, for example, you can build agents that would look for research papers that have already addressed this specific issue of menopause prediction or menopause symptom onset prediction and see what kind of models those scientists that have published research papers were using and what were the results. For example, you can find a paper that explains how sleep quality changes, deteriorates when the menopause onset is incoming, which gives you some information about how this specific feature of, say, sleep regularity or sleep duration can affect the menopause onset. What is the magnitude? What were the input features used? And that gives you a small piece of information and guides you towards selecting specific features for modeling. Or then you can find some other papers that describe the genome expression and how different regions in genome are contributing towards changes in your hormonal balance and obviously lead to the menopause. If you find papers like that, again, you can use this information to gather data about the input features that you might use, how they affect the target variable, and essentially get like first distributions of potential influences of different features on your target variable from the existing research body, from the existing papers. That basically gives you expectations of how features are supposed to affect your target. And then as you start building your own models with the data set that you collect, this will be a separate stream of your work. You can cross-reference that to the scientifically backed data from the research papers and understand if your model is going in the right direction or not. Because obviously you can build a model that, say, performs quite well on your training data set, but what if you collected the data in a wrong way? What is there a leak? What is there some problem that's intrinsic to the data set that you've collected? If you have this reference scientifically backed research grade guidance from the research papers, then you can again validate and cross-reference your results and understand if your model is behaving in the right way. For example, again, getting back to this example with the sleep quality, we know that as menopause approaches, as you approach the symptom onset, the sleep quality deteriorates heavily. That includes the number of wake-ups, the sleep quality, the sleep duration. If your model says otherwise, and all of a sudden there is, for example, the sleep quality improves, and that is a good signal for your menopause symptom onset, likely something is wrong with the data, and you can validate this using the research papers. Yeah, so that was my rant for 10 minutes. Now I will wait for your questions. I shared my thinking about this challenge, but yeah, obviously challenge that. Let's see what questions you might have, and I'm here to answer them. So please go ahead. Okay, I can see the first question. I will read them aloud so that everybody hears that as well. So I've gleaned my synthetic menopause dataset and done correlation analysis. What's the best next step for modeling? Start with something interpretable like linear regression or jump to XGBoost for nonlinear patterns. I would say that for any machine learning task, it's always advisable to start with a very simple model. The simplest you can get, the better. For this challenge specifically, if you are using, say, nonlinear patterns, linear regression, so I assume it's a regression task in your case, try with a very simple static baseline, literally predict an average and see what would be the quality metrics, then move on to models that like linear regression, see how it beats your naive baseline, and then move on to more complex models gradually, because that way you can control if advanced models are actually learning something meaningful or not, and you can see the gradual quality improvement over time. So that's always useful to start simple. Yeah, thank you for the question. I see a raised hand. Is there a question?
Um, yeah. I'm Svetlana. Nice to meet you. Thank you so much for doing this. That's awesome. Um, so I think for me, I have quite a lot of years of experience in like blood research and like ML, data science, all of this. Um, I'm thinking, could you talk a little bit like what do you think is the most interesting question to answer with this challenge? Like overall, like what is the goal? So like what are we trying to do? Because I feel like if we think of um like prediction of symptoms onset, like are we trying to predict this beforehand, trying to help women to, I don't know, be prepared,
Mhm.
or and also because I mean generally there is like premenopause, then there is perimenopause when hormones go all over the place, and
Yeah.
this is like specifically challenging time for women, because this is like where symptoms start, and one day you may have symptoms, next day they are gone, and then they're back. And then once it kind of cools down, estrogen's down, and a woman goes on menopause. So I'm curious, like in terms of like the actual value
Mhm.
to like patients, in this case, like women, pretty much
Yep.
every woman that will go into menopause at some point. Like, what is the biggest value in terms of like because thinking like I don't know like in a certain number of years when it happens to me like I'm thinking like okay like even if I know that it is supposed to happen
Mhm.
in like
Mhm.
5 years as opposed to 10 or 15 years, like what is the actual value to me, right?
Yeah. Yeah.
um yeah, so just like curious what you think about this.
No, that's an amazing question. Thank you for that. My personal take, and I think the company I work at aligns with this vision, is that it should be actionable. Because if you just have information about, hey, you're going to face this issue in the next year, so what? Like, it's just going to be yet another scaring factor for me. That's it. So the more actionable the things that we measure could be, the better. For example, if we know that your sleep quality is going to deteriorate in the next future, what actions can you take to prevent this from happening or to make the symptoms more mild? Could this be that you pay more attention to your sleep routine? You take melatonin, you take some supplements that help you with this irregular sleep that is a symptom of the menopause. Same with the physical activity. We all know that it's going to get harder for you to exercise, especially during the perimenopause and menopause period. Does that mean that you can take some actions beforehand and maybe exercise before these symptoms start? Maybe there are some special physical therapies that you might undergo to again make those symptoms milder. Finally, there is the hormonal therapy, and many women they choose to opt into hormonal therapy when they go to this turbulent perimenopause period. Again, if they know beforehand that, hey, this is happening to my body, this is what I'm going to experience, they can reach out to doctors proactively instead of reactively when they have already experienced all the changes and have felt all the symptoms. So I think that would be the most valuable part of it. How can we detect things early on so that you can act on them? And if we know what are specific things that are changing in your body, be it sleep or physical activity or hot flashes that you get, maybe we can recommend different approaches and different ways to act on those changes. But again, that is my take. And personally, I like this actionable approach, especially when it comes to health, because it's fine to be just aware of things happening, and it would be great to have a solution that just predicts when menopause is going to happen, because many women are actually unaware as they go through the perimenopause and menopause period, they are unaware that this is happening to them. And doctors, they often overlook the symptoms as well. They attribute this to something else. So, robust detection of menopause, robust detection of the symptoms that are associated with menopause is valuable on its own. But yeah, for myself, the more actionable it is, the better.
Yeah, yeah, thank you. um yeah, I have a few more questions but they can wait if don't want to like
Well, no more raised
Great.
hands so far, so please go ahead. And
Yeah.
yeah, if other people have questions, just raise your hand so that I know who to move next.
Okay. Yeah. Well, I was also thinking, like, as we were talking, because I was thinking, like, I guess it is true that even though now there's more and more conversations about menopause and perimenopause, like, still not everyone knows this, or you may
Mhm.
think, like, oh, it's something that may not apply to me yet, and then it may just happen. But I was thinking, do you think it's also maybe valuable to have something that is maybe so okay probably women that already invest a lot in their health, like have like Aura Ring or like did a lot of other monitoring. I don't know, like sleep on a smart mattress and stuff like this. Probably those women, they do collect a lot of data, and for those, it's probably easier to predict. At the same time, probably this population is already like very
Mhm.
fine tuned with their body, and they like kind of already know what is going on, what may happen. They stay on top of like their like doctor appointments and things like this. At the same time, there is a huge population of women that don't have access to any of these like fancy tech. So could it be something that like it could be interesting to build like a simple model? It could be like an app. You don't need much. You don't need any like special devices. Maybe like answer like a questionnaire. Maybe we can like ask women, I don't know, to just track their sleep for a
Mhm.
few weeks and I don't know, log things manually so you don't even have to buy anything.
Yeah.
And then I think like it could be pretty valuable for women that are yeah, don't have access to
Mm.
all the resources.
Yeah. I definitely like this way of thinking, and I think this could be a very nice continuation of the topics that we were just discussing with collecting the data, finding explainable patterns and correlations. Because if you identify a few key things that really predict the menopause onset, these could be the basis for the questions in the questionnaire for the app that you were just describing. Because obviously, the biometrics data is the best when it comes to menopause, and genome data is the best because we can see those changes happening. With the questionnaire, it's going to be a bit more challenging because we don't really observe the full context, and the only thing that we can get is those occasional feedback that users of the app might give us. So maybe that could be a great approach to first build a model or build those correlations, understand what are the symptoms, understand what are the questions that we should ask so that having those answers, we can definitely say if there is a perimenopause, if there is an onset or not. Yeah, I generally like this idea.
I like this. Thank you.
Thank you. There is another question in chat. I'll answer that first, and then I'll go to Rohan. So, question: is it more important in this challenge to predict menopausal symptoms using biomarkers, or is it more important to predict positive correlates, such as positive aspects of lifestyle, exercise, healthy aging, etc.? Um, that's a great question. I don't really have a definitive answer to that because I think either one of those paths is would be great. It all depends on what data you can collect realistically. Because if your data is purely about biomarkers, fantastic, then you can use those and predict the symptoms based on biomarkers. If you get your hands on the data that's largely demographics, lifestyle, health exercises, etc., then it's fine building the data set and the model using this kind of data. That's why in the beginning I was saying that collecting data set would be the most challenging part of it because it literally defines the outcomes that you can potentially get. So if you are interested in biomarkers, go ahead. If you don't want to spend too much time looking for this medical grade data, but you have a great open source data set with lifestyle, amazing, just use that. As long as you have good labels for the onset for the symptoms, just use that. But yeah, I can't say that any of those paths is more important than the other. Either is great. Thank you. Uh, I have one hand raised by Rohan. Please go ahead.
Hi.
Hi.
Uh, I, so I wanted to know once the models are built, and as you mentioned earlier, uh, like if we need to suggest uh, some precautions, or some ideas, preventive measures, right? So can we use large language models for it, or do we need to hardcore the advices basically?
I see. Yes.
Yeah.
Uh, well, for the hackathon at least, using LLMs is absolutely fine because why not? As long as you can write creative prompts and actually guide it to be safe enough, that is completely fine. For proper real life settings, you definitely would not get FDA approval if you just use a straight LLM to give medical advice. But again, for hackathon settings, that is completely fine. You can start building your prototype using LLMs. You can give insights and guidance, and it will generally do a great job in that. I mean, we've tested this out extensively as well, both internally and with some members. The problem with like consumer devices or with actual companies is that you need to prove that your models and your algorithms are safe, largely deterministic, which is not the case with LLMs. And if you are actually putting out an LLM solution to the market, you need to make sure that it will not do harm, and especially when it comes to medical advice. So if, for example, your plan is then to scale this up, build a company around that, build an app or a feature, there you might rethink this approach and maybe pre-generate the insights with LLM so that you are fully aware of their content, they are deterministic, they are safe, as opposed to being generated on the fly and you have no control over that. But again, for hackathon, completely fine. I think that's a viable approach.
Thank you.
Thank you, Rohan. All right, any other questions?
Hi, Dima.
Hi again.
Happy to see you. Thank you for
Hi.
your detailed explanation. Please see our chat. I have sent from Stream YouTube questions about ML models. And I didn't catch all the answers addressed to Svetlana, but I think to collect biomarkers from using automatic pipeline, it's a pretty complex task too.
Yeah. I think I have answered those questions about the models already from YouTube. So are there any new questions in there?
Mm.
No. Rohan, go ahead.
Yeah, sorry, if I like, okay. Here's the question, like what's the success criteria? I
Yes.
might have missed sorry. Yeah.
Yeah, that's a great question. That is something that we were actually actively discussing as an org team. What would be the success for this challenge? Because obviously the North Star here is to build a model where you can measure accuracy of the predictions and then report on the results, like why it behaves like that, what are the features that affect the menopause symptoms, onset, etc. But this is a North Star, this in my opinion, and collecting a good data set and proving that you can use this data set to find meaningful correlations and do some analysis would be a great success, in my book at least. Building a model, I would say, would not take as much time as building a great data set. So if you managed to find good labels, interesting data to play with, and then you've created some visualizations, built statistical analysis, that is already great. If you take the next step of actually building a model and then having the interpretation of this model, that would be fantastic. And then obviously there are alternatives like Svetlana just mentioned. Maybe you want to build an app, then you might not even need a model. You just build the insights, the advice based on the correlations that you find, based on the scientific data and the data that you collected, and here's your final product. So there could be some creative ways of doing that.
Thank you. Can I ask one more follow-up question? If
Yes,
it's
go ahead.
okay. Yeah. So it's not like a traditional hackathon wherein some data set is given to the students and there is a hidden data set, kind of a test data set,
Hmm.
which is tested upon, the
Yeah.
solutions are tested upon. So
Yes.
rather than that, it's an open-end hackathon wherein
Hmm.
most of the importance is given to the fact how good of a data set you are coming with, how good your research is for that, and then using that data set to generate some insights out of it, the high level picture, right?
Alina can correct me if I'm wrong, but that is my understanding. Yes. Well, obviously it
Okay.
is an open-ended challenge. There is no hidden test set. It's not like Kaggle competition. So for sure it is more open-ended and you are supposed to come up with a solution to finding the data, building models, building an app on that or just a web interface. And because it is such a big challenge to find a good enough data set, unless you found like an existing one that is just perfectly fit for this task, it would be great if you can just prove that your data set is valuable, that you can find meaningful discoveries in there, that you can build insights using this data set, and preferably a model. So I would say that if you are going the route of using a ready-made data set, you just found it on open source data, Kaggle, whatever, then what would be expected of you is a model that's 100%. And if you are going to collect the data on your own, maybe you combine multiple data sources, clean this up, ensure that the labels are consistent and fine, then just having the analysis done using this data set would be great.
Thank you.
Thank you. I have another raised hand. Please go ahead.
I think it's me, right?
Yes.
Hello.
Hi.
Thank you so much for this meeting. You can hear me correctly, right?
Yes, yes, all good. All good.
Amazing. I had a question. I'm not so into programming part. I'm more in the research part, but I will try to um, ask as much detailed as possible. So, uh, for the collection data for this data set, the question was raised to use synthetic data set, but would you recommend some proportions with the real data that we can access, for example, with the sworn data set, right?
Yes, yeah. I would say that synthetic data generation usually doesn't help with health-related problems. And maybe there are some corner cases when you have severely imbalanced data sets when this synthetic data augmentation might help. But I would say that it's best to focus on the real high quality data. And if you only have a handful of observations, that is fine. Just build lighter weight models instead of trying to synthetically generate as much samples as possible so that you can trade something more, like something heavier. Because it is one thing to use synthetic data generation when you, I don't know, play with images, for example. There, this is essential to augment the data to see all the different kinds of images that you can potentially produce. With health data, specifically this kind of health data, when you need high quality labels, when you are dealing with biomarkers, I don't think that usual synthetic data generation techniques could handle this task properly. So ideally, just focus on the data that you have that is real. And if you don't have many samples, use smaller models or just use statistical analytics tools like correlation analysis, for example.
Thank you very much. A little bit further following the same idea, um, do we can we actually use cross-sectional data sets, as I understand? Um, well, yeah, that doesn't matter how I understand. How do you think, can we use that or not?
Oh, sorry, what do you mean by cross-sectional?
Yeah, that's the part that I was really afraid, because I'm not sure I understand it correctly. I
One
think not.
time point, she means not longitude, not different
Yeah,
time points.
Okay,
One
I see.
baseline and all.
Mhm.
thank you.
I see, I see. Uh, I would suspect that most data sets would be like that, as opposed to having continuous time series observations, unless you find a data set uh, that comes from wearables sources, because that's where you usually get continuous health data. So again, I think it's fine because even with the cross-section where you don't have time series, you still can find meaningful insights and build models. Because if this data set is representative of different ages of women, that kind of gives you this time series nature anyways. You can observe how the symptoms can manifest themselves, I don't know, in women in their 40s, 50s, 60s, etc., and where exactly the menopause onset would happen and how it can be shown in different biosignals. So yes, it's completely fine if you don't have time series, you have this cross-sectional data set, as long as it is representative. Because, for example, if you have just women in their, I don't know, 50s undergoing the perimenopause, then how would you know when the onset actually started and what were the most important features? You just have this single slice of specific age of women. So it's best to aim for better representation of different ages in those kinds of data sets.
Yeah, and as I can say, it is the most problematic part because the recommended data set that we mostly probably used takes long-term um, data collection, and it is easier to work with, but unfortunately, it doesn't have a lot of criteria, right? And this is the third question that I wanted to ask. What is better to, how to say, more parameters, in terms of questions, and you got me. Or it is better to build a more accurate model on the less parameters, or better add more for variability in this case,
Yeah,
but
yeah.
with less quality maybe.
Yeah, that's a great question. So technically both options are viable, and in research settings it is more often that you observe data set with limited number of participants but very large number of different columns, observations, and questions. And that effectively means that you cannot use, say, machine learning tools to analyze this data. You would need specific statistical tooling that can address a large number of features as opposed to large number of observations. It's just going to make it more complicated to analyze this data, because the more features you have and the fewer observations, the more vigorous you have to be when it comes to even correlation. You can't really just go ahead and run correlation for all the features. It would be spurious. So there are more vigorous statistical testing that has to be involved. And now for the second case, when you have more observations than features, which is an ideal case for machine learning models, that's where you can build your standard linear regressions, XGBoost, you name it. And that would be meaningful and reasonable to do. So if you don't want to get too deep into the research statistical analysis, I would suggest you to focus on a fewer number of features to work with and try to find as many observations as possible. And if you are fine dealing with lots of statistical testing instead of building models, then opt in for higher variability, more features, and maybe smaller observation number.
Thank you. Appreciate the answer. Helps a lot.
Thank you.
And in this case, I kind of connecting with the previous speaker, Svetlana, if I remember correctly, why this challenge was asked. So generally, it is a tool to help women, and this tool to help women that are not familiar with uh, data analysis, with any approaches for scientific terms or whatever. So in this case, if we, for example, want to focus on more use for a simple user, right?
Yeah, yeah.
Probably the first, how to say, probably it would be better to focus on easier something that we can easier say that it's like, yeah, this is correct. Based on our data, maybe with a little bit of parameters, but this is like highly correct, and we can give a simple answer, so yes or no. Or it would be better to represent in the case of like you have this possibility, or try to break down the complexity of the size, because on both hand it can happen. Okay, I hope you
Yes, yeah, I think I understand the question.
Thank you.
But let me think for a moment. I think that there are two parts to that. First is more educational. What even is menopause? What it takes to get to the symptom onset? What can happen to your body? And largely, that could be part of the challenge. Understanding what are the different things that go off, and can we predict them based on all the different data that you can collect. This is more of an educational part. The second part is, as I mentioned was it Svetlana, the actionable part. Are there things that you can meaningfully change in your behavior, in your physical activity, in your sleep routines, hormones intake, etc., that can mitigate or at least make the symptoms more mild as you enter the perimenopause period? And with this actionable part, obviously you cannot change your genome expression, for example, right? But if you know that, hey, my sleep is now going off the charts, largely you can fix this either with medication or with better sleep hygiene. So these are the things that you could focus on if you care about the actionable part as opposed to the educational part. But again, I would say that both routes here are very, very interesting. The challenge itself says that the like menopause effects, they would affect every woman, but the severity and the timing is largely unpredictable. So that is the essence of the challenge. Can we even predict when the menopause is going to hit, when the symptoms onset would happen, or is it completely random? So finding this signal, even if it's not going to be actionable, but just educational, is still extremely valuable and important. And I would say that it's up to you to decide which route you want to take, but both are equally valuable. Hope that answers the question, although I didn't give you a definitive direction to go with.
Yes, it is still very helpful. Thank you very much. If I come up with something else, I will ask more.
Yes, please do. Rohan, I see raised hand, but there is one question in chat, so let me read this aloud. If we want to predict menopause with our model, we should use a longitudinal data set, right? Is there a workaround for this? Can we at least partially use cross-sectional data sets?
Oh, it's my question. I already got the answer.
Oh, yes. Okay. Okay. Thanks. Yeah, because I don't have YouTube stream open, so I can only read the questions in Zoom. Sorry. Rohan, go ahead.
Yeah, one more question. So earlier you mentioned the usage of LLMs during the experimentation part in your team. So I wanted to know, like, how do you ensure interpretability and trustworthiness when you experiment with LLMs or AI agents as such, especially for this sensitive health data domain, you know?
Yes.
Yeah.
This is still an unsolved problem, but the best way of ensuring that LLMs are more or less safe is have an evaluation tool or evaluation set. Essentially, these are the question answer pairs that you write yourself manually. Those could be based on scientific research data or subject matter expertise, where you explicitly say, okay, this is the question, or this is the data, this is what the output should be. This is the gold standard answer. Like, for example, a question answer pair here could be sleep that is now disturbed, it's shorter, it's poorer. Is this a symptom of a menopause, yes or no? Or does it lead to menopause, yes or no? And if LLM fails to answer that or answers this incorrectly, you go and fix your prompt, or you go and change the provider of an LLM. If it answers correctly, it's essentially a unit test passed. You go to the next question that, again, you've manually written. You have scientific validation of this answer, and then you expect the LLM to perform equally well on this eval set. So if you want to go this route and you want to build, say, an insights engine which is powered by an LLM, and it generates insights based on different inputs, different context, then I would suggest spending at least some time thinking about this evaluation set of questions and answers, which again can be built with the help of an LLM. Because imagine you have 100 research papers that discuss how different symptoms are manifesting themselves when menopause hits, and you can generate a bunch of question answer pairs that would going to be golden, like truth, scientifically backed truth, and use this set as your evaluation for whatever LLM you are planning to build to generate the insights.
Understood. The So my plan of action is to use an LLM just for the insights part of it,
Mhm,
so that it is more interactive,
mhm,
and the answers, it can be interactive with the users as well, so
yeah,
that every user gets a personalized answer or personalized insight based out
mhm,
of how the user asks the questions.
yeah, yeah,
Yeah, so it will be kind of a plug and play
mhm,
option. Yeah.
yeah, I see. Yeah, I think that is then exactly the case. I can imagine a scenario where this LLM is being used as like a guidance, as an advisor, where a woman might ask like, hey, recently I've had those sleep disturbances and something is off. And then LLM gives you an insight, maybe with an underlying model that actually predicts if there is a menopause onset or not. And then LLM explains what is going on, maybe explains the symptoms. So I think it's a completely viable approach again. And if you want to test this properly and validate this properly, you could have this evaluation set generated based on the research papers. That would be a good way forward.
Okay. Thank you so much for the answers.
Thank you. All right, we still have 15 minutes left. Any more questions? Yes, go ahead, Tammy.
Thank you so much. So my question was, since our project involves health-related data, even if it's synthetic, how much emphasis should we place on ethical AI and data privacy when we're presenting our solution?
That is an excellent question. First of all, I would expect that if you go and collect this data, or take this data from publicly available sources, then you respect the policies that the data sets are coming with. I mean, usually it's just non-commercial use, which is obviously the case here. But in general, for the open data sets, it's fine to build the models, to build some solutions and products without really worrying too much about the privacy of these data sets, because they were originally de-anonymized. They are properly prepared for public use. So there are no additional considerations that you need to take care of. It might become a bit more tricky if you build a working prototype that is now collecting the data from other people. And let's say there are questionnaires, right, that are going out, and you expect people to answer those questions, and then you do something with this data. That's where you need to start thinking about privacy of this data, how you store this, and all the associated regulations like GDPR or even HIPAA, if that's like medically grade data. For the sake of hackathon, I don't think that is necessary to think about those things. You should mention them in your final solution. That would be great. That, say, it's in your roadmap as you go forward with your solution, or you want to build a consumer-facing product out of this. Then it's great if you have thought about this. And these are the points where you collect the data. This is how you're planning to store this. This is how you plan to address the GDPR compliance and the HIPAA compliance and all the other things. But I don't think that it is necessary to implement them straight away. your primary goal here is to build a working prototype or collect the data and build a working model, as opposed to paying too much attention on how to make this all safe and compliant. But yeah, it's great to think about this, and it's great to mention that in your final presentation.
Thank you so much.
Thank you. Yes, one more question.
Hello again. It is a continuation for the previous question. So it will be enough if we just mention it in a presentation and, for example, in our repository, because eventually we all gonna be there, right? Just put the data about our metrics or about which data sets we use.
Yes. Yeah.
And in terms of data from publications, well, there might be a little bit. So in this case, we can use only data with open access policy.
Ideally, yes. It could be obviously paywalled, like if you're using, I don't know, UK Biobank and you want to spend those 200 quids to actually get access to that, it's fine. I think ideally you should just cite your sources as in proper research, because if you get access to a specific data set, mention that this is the data you're using. If you collected it on your own using publicly available sources, list out those sources. If you are using research papers to generate insights or get additional data, cite those sources. That is the best approach.
Okay, thank you very much.
Thank you. Right, finish line, 10 minutes. Anything else?
Oh, I had another question while nobody's asking. Is it possible with a little bit more detailed questions, like a little bit more deep into the data or anything, ask directly or maybe send a list of questions somewhere in the case of advice, more like with the details, so what, I don't know, methods maybe, or about the metrics that we used or something else.
Sorry, not sure. To send those questions where exactly?
Yeah, like address it in a maybe in a Discord or
Oh, yes.
directly ask the mentor, because these questions are a little bit more technical, not
Absolutely.
so general.
Yeah, absolutely. And just feel free to ping in Discord or write in the channel that we use for the challenge, the menopause symptom prediction. Right away, I'll try to answer them all, usually during the evening times because I have work. But yeah, please write those questions and share them.
Okay, thank you.
Thank you. Rohan, go ahead.
Yeah. So, so my domain is in AI and ML, and I have I have no idea about this domain, right?
Mhm.
So I wanted to know, like, how, like, what should I do whenever I
Right.
am building AI models in a different domain as such?
Yeah. Excellent question. I would say that asking ChatGPT would actually be a nice way to solve this, because if you have a prompt literally like that, hey, this is the challenge. I'm planning to do this specific thing with the data. What would be the best way to solve this as a data scientist, for example? Then I would guarantee that ChatGPT would spit out something that's more or less reasonable that you can use, as long as you have a very structured approach and not just, hey, here's the data, please solve everything. Try to take it step by step, because first you need to collect the data, then clean it, make sure that it's useful, then try with the simple models, prototypes, move on to the more complex models, keep all the metrics in check. So these are all the different steps that ChatGPT can help you with. And yeah, I think there are a lot of opportunities for non-technical people to participate in technical challenges these days, because I mean, even I, as a data scientist, most of my code is now being written by Claude instead of myself. So it's completely fine to rely on AI tools, and this challenge is no exception.
Yeah, I went through multiple research papers as well yesterday. Uh, Came along different hormones, which
Yes,
which I never heard of. But yeah, I'm getting the hang of it now. The correlations of these hormones in between them and
yeah,
how they affect sleep cycles and everything. So yeah, I'm getting the hang of it. Yeah, thank
perfect.
you.
Good luck there. Thank you. All right, 7 minutes. Few last questions before we part.
I have another question, I think.
Go ahead.
Well, yeah, again, nobody is asking, sorry, without a hand. My friend just wrote me, can we show the case where we use synthetic data in another demonstration, like an additional, as I understand that? Um, as you mentioned, if we use just fully synthetic data, it's not going to be like that accurate, but can we?
Mm, not sure I completely understand the question, but let's say if you run a demo of your model and you want to showcase how it would work for different cases, then obviously you can generate those cases synthetically. This would be a few additional rows in your data set that you can run, sorry, and explicitly show how the model would perform. Like that part is completely fine. What I'm a bit skeptical about is if the model is trained purely on synthetic data in the first place, because then you cannot really guarantee that it is uh, accurate, viable, or useful. It is literally being trained to replicate the rules you were using to generate the data set, and that doesn't really make sense. So ideally, use as little of synthetic data generation as possible. For demos, it's completely fine as additional examples that were, say, unobserved in your data set. But for training, it's best to use something real, something tangible.
Yeah, thank you. As I understand the question myself, because it's hard to translate from a professional question to a for me. So if we just make this case like as a different scenario, so we try to teach the model on the synthetic data set as well and show it additionally, would it make any sense, or we just need
I
to
see.
focus on
See.
what
I
we
mean,
do primary?
yeah, got it, got it. I mean that obviously is technically doable. I just don't really see much value in doing that because uh, the whole point of a model is to find and discover the relationships that are hidden in the data. If you are building a synthetic data set, that literally means that you have all those relationships in mind beforehand. You to generate the data, you need the rules, right? And these rules are dictating what the model would eventually learn. So to me, it doesn't make sense to use purely synthetic data set to train a model, because why would you train a model if you have those rules in the first place? This is the answer already. Like if, for example, you want to generate a synthetic data set where, I don't know, for every 10 minutes of sleep loss, the probability of specific symptoms of the menopause onset increases by 5%, and then you generate all this data with different distributions and other parameters, the only rule that your model is going to learn is exactly the same that you use to generate this data. So it's got to be the same relationship. That's why I'm a bit skeptical about synthetic data generation.
Yeah, totally understandable. And I guess in my case, it would be interesting to see if the real data set
Mhm.
will match with the possible synthetic model. Like,
Sure.
will it
Yeah.
actually be different?
Yeah. Yeah. I mean,
Yeah,
yeah.
that's a speculational moment, kind of.
Yeah.
Thank
And
you
again,
again.
it depends on how you build the synthetic data. If you base it on the, well, real data set distributions, when obviously it will match. If you use something else to generate a synthetic data set, then it won't match. So again, you kind of know the answer beforehand. It all depends on how you get the synthetic data in the first place.
Well, one of the tools that were recommended, I guess, quite useful, the tofu, Spirus tofu, if I remember correct,
Okay.
that takes data based on Swan data set and generates synthetic data set based
Okay.
on that. And that's quite interesting approach. So we have the already processed data in this case, and based on already existing processed data, we generate a synthetic one.
I see. Yeah. Then again, this is a viable approach. This is how the synthetic data is generated. The question here is, what are you generating this data for? Because if you have data hungry models, like, I don't know, deep networks, transformers, whatever, then for sure they would need large quantities of data simply because of the nature of the model, how it's being trained. But it won't learn any new patterns or anything in addition to what already existed in the original smaller data set. So if you want to just explore what's in there, what's in the data, and the sample size is small, build lighter model, and you will get the same results. But yeah, obviously it is doable. It is a viable approach. Yes, Sophia.
Yeah, I'm so sorry to interrupt. Hi there. But we have another discussion like in 4 minutes.
Oh, okay.
So
Yes,
sorry,
thank you.
deeply sorry to interrupt.
Yes.
Well, may we finish now? I think.
Perfect. All right. Thank you.
Anybody have a question maybe? Well, thanks a lot. Thanks a lot.
Thanks, everyone.
Thanks a lot for such a discussion. Thanks a lot.
Bye.
And the translation will be available on our YouTube platform.